So in the last class, we have seen first order logic. Now we will see quantifying uncertainty. And what is uncertainty? So basically, uncertainty is the lack of exact information or knowledge that helps us to find the conclusion. Suppose you have one condition that action A, T, let the action AT be leave for office at T minutes before opening time. With AT, can one get office on time? So it's an uncertain because the manufacturers will affect this time, whether the person can uh, enter the office or reach office on time or not. So many possible problems can be there. One by one, we will see what are the possible problems are associated that will affect the time to reach the office. Partial observatory road state. So partial observatory cannot observe the full state of the system. For example, in this situation only, while predicting the whether the person can reach office on time or not, so there it is difficult to predict because of the road condition or the traffic condition, and the data might not be complete for the condition. Second one is noisy sensors, traffic reports forecast. So the sensors can be physical or digital that often introduce noise into the data they collect. So the traffic report or forecast that may be inaccurate or delayed as they depend on the data collected from the sensors. Then uncertainty outcomes, flat tires. So another possible problem can be the although the current state of a system is well known, certain outcomes are still uncertain. For example, car is predicted to be running smoothly on a well-maintained road, but due to unforeseen events like a flat tire can occur randomly, disrupting the predictions. So that situation may also come. Then immense complexity of modeling and prediction. So real world systems like traffic flow or mechanical failures are complex. So the factors like weather condition, human behavior, vehicle performance, etc. can influence a system, making it difficult to predict. Or more complex a system, harder is to predict with certainty. So these kind of problems may occur, which can lead to uncertainty. So in this case also, that kind of problems may occur while the person is going to office. So how we can handle the uncertainty? So we have to make some prior assumptions, then some rules of first factors, probability, fuzzy logic. So while dealing this, we have to use this. And as the first order logic is a formal system used to represent facts, relationships, and reasoning in a structured way, but struggles with problems involving uncertainty. As I already told, that first order logic is difficult to deal with the problem of uncertainty. Uncertainty problems require methods that deal with probabilistic reasoning, noise, incomplete information, and stochastic outcomes which first order logic cannot handle. Then we require probabilistic reasoning, Bayesian reasoning, temporal reasoning, fuzzy logic for better dealing with uncertainty instead of first order logic, which we will see in the upcoming slides. The probabilistic reasoning are used when output and outcomes are unpredictable. So probability you might have heard already. So that is required to calculate the uncertainty and such kind of situations. to deal with such kinds of situations. Then it is a measure of degree of likelihood of occurrence of that event or probability of an uncertain event. So the sources of uncertainty here it is mentioned that human error, experimental error, random error, equipment error, environment variation. As already I have explained in the possible problems. So this kind of uncertainty are associated so that we have to deal in such a certain situations and certain kind of problems while solving them. Then uh, ontological commitments and epistemological commitments I have mentioned here. So the logic world is composed of facts that do or do not hold. So maybe one statement is correct or it is not correct. So directly we can tell. And in epistemological commitments, so each sentence is true or false, or it may be unknown also. Then the logic is no in between, only either true or false. For the ontological commitments, and the probability theory is the only difference is that is how uncertainty is expressed about the facts. Means the fact is holding or not. Then comes the epistemological commitments. So how each system represents knowledge or belief about the world. And the logic is each sentence or proposition is true or false, or it may be unknown also. Like for example, road is wet. Either it is true or false, or the truth value is unknown. And the associated probabilistic theory is numerical degree of belief between 0 sentence for certainly false and 1 sentences are certainly true. So we will uh, associate the true with 1 and false with 0. Or one more thing, it might come that it will be in between 0 and 1. That is the uncertainty or confidence that statement is true. So if it is towards the 1, then it is certainly the statement is true. So that also we can consider. Now moving on to the probabilistic reasoning. So probabilistic reasoning here, as I have already mentioned, to deal with the uncertain situations or uncertainty. Uh, this representation of knowledge of the first order logic and propositional logic already we have seen. This A implies B, which means A is true, then B is true. Then representation of uncertain knowledge. So in that case, we have to use the probabilistic reasoning. For example, if A implies B, which means A is true, then B is true, but consider a situation where we are not sure about whether A is true or not, and then we cannot express this statement. This situation is called uncertainty. So if the A itself is not true, then how can be the B be true or the statement does not hold? So there uncertainty situation will arise. So it is the way of knowledge representation and apply the concept of probability to indicate the uncertainty in knowledge. So the causes of uncertainty in the real world can be information occurred from unreliable resources, experimental errors, equipment fault, temperature variation, climate change. So these are the causes which affects the uncertainty and or which gives rise to the uncertainty. The the data we are collecting is may itself has some mistakes or some uh, uncertainty in the data. So to deal with that, we will be using the probabilistic reasoning. So before that, we have to see the uncertain event. So what is an uncertain event? It is outcome or occurrence that cannot be predicted with complete confidence due to incomplete information, randomness, or variability in the underlying factors. For example, predicting rain on a specific day. So uh, rise or fall of stock price, rolling a dice, or flipping a coin. So some of the uncertain events which may occur. So in these examples, you can have the idea. So we are using the probabilistic reasoning in AI, where the outcomes are unpredictable. When the specifications or possibilities of predicates becomes too large to handle, or when an unknown error occurs during an experiment. So in that case, we are using probabilistic reasoning. So probability can be defined as the chance that an uncertain event will occur. And the probability of an event A is greater than equal to 0 and less than equal to 1. If probability of A equals 0, then it indicates total uncertainty in an event A. And if probability of A equal 1, then it indicates total uncertainty in an event A. Total certainty in an event A. So the 0 will indicate the uncertainty, and the 1 will indicate certainty. That we will see with an example in the later part of this slide. So here the probability of an uncertain event, how we can calculate. So here it is mentioned in the formula how we can calculate probability of occurrence, the number of desired outcomes divided by total number of outcomes. Then the probability of A under the conditions of B will be PAB equal PA logical and B divided by PB. Then the probability of B under the conditions of A, PBA, PA logical and B divided by PA. And PA and B will be the joint probability of A and B, which is you can see in the diagram. the A and B and the joint probability of A and B. So here we will apply the Bayes theorem or the Bayes rule to calculate this. This we will see with an example. So the joint in this formula, the conditional probability which we are calculating through the Bayes theorem is the event A occurring given that B already occurred. Then we will calculate PAB. And the joint probability, this you have seen in the diagram, and the marginal probability PB or PA, whichever we were calculating. This is the probability of event B occurring or event A occurring. Let's see an example. So in a class, there are 70% of students who like English and 40% the students who likes English and mathematics. Then what is the percentage of students, those who like English also like mathematics? That we have to calculate. So this kind of calculations we can calculate with the probabilistic reasoning, which we cannot calculate with the first order logic, because there are some conditions or uncertainty involved in the situation. So how we can calculate? Here it is mentioned clearly. how it can be calculated. So let A is an event that a student likes mathematics, and B is an event that a student likes English. So both we are uh, uh, taking as before calculating using the Bayes theorem. The event we are mentioning as A and B. Then PAB, what we are going to calculate is the percentage of students who like English and also like mathematics. So here just we are taking the values. EAB is 0.4, 40%, which is already mentioned in the problem, as students who likes English and mathematics is 40%. Then PB, that is only 70% of the students who like only English. So that we are calculating and getting 57%. So you can calculate 50% are the students who like English and also like mathematics. So in this example, you can see how Bayes theorem can be applied. Just see once before moving to the next example.
So can you explain the question? 40% English and mathematics, and those who like English also like mathematics. I don't understand the difference.
Yeah, so in a class, 70% of the students who like only English, and the 40% of the students who likes English and mathematics. Total 40% likes the both the subject. So 40% on both subjects are liked by the students. Then the percentage of the students who like English and also like mathematics. So the among if these students are liking English, then they will also like the mathematics. So that we will calculate here.
Answer will be 40% only. No.
No, answer will not be 40%. Actually, this question here, total 40% likes both the subjects, and this is what we are calculating that if the students already like the subject English, then also like mathematics. So it may or may not be like that uh, among the 40% also that both subjects uh, are liked by the students.
Excuse me, sir.
Yeah,
Hello.
yeah. Tell me.
Hello. Of this
Yeah, yeah,
4 divided by 0.7,
yeah,
right, sir? So the 0.4 is the 40% of the students who like both English and mathematics, right?
yeah.
Which is going to divide it by the students who like English.
Mm,
So
yeah.
should it be total number of the students divided by the persons who like only English, right, sir?
What you asked? Can you repeat?
That what is the percentage of students, those who like English as well as mathematics?
Hmm.
So, in the case of the calculation part, it shows that the 0.4 divided by 0.7, it is quite confusing since it's not understandable. Can you make it easy to understand, sir? Like why it's 40 divided by
Yeah, this one we have to see again this question actually.
yeah.
Yeah.
Okay, sir.
Mm. Okay, then this I will again solve it and again I will share with you. So next question we can see this I will see again. So next question is what is the probability that a patient has disease, this meningitis, with a stiff neck? Already the data is given. Uh, Doctor is aware that the disease meningitis causes a patient to have stiff neck and it occurs 80% of the time. He is also aware that uh, of some more facts. The known probability that a patient has meningitis is 1 out of 30,000. And the known probability that a patient has stiff neck is 2%. So how we can calculate that patient out of total how many patients has meningitis disease with a stiff neck? So let A with the proposition that the patient has stiff neck and B with the proposition that patient has meningitis. Then we can calculate EAB, which is already given that patients having meningitis have a stiff neck that occurs 80% of the time, so 0.8, and the patient having meningitis disease is 1 by 30,000, and patient having stiff neck is 2%, 0.2. Then we are calculating that uh, out of how many patients that one patient will be having meningitis disease with a stiff neck. So that count we have to calculate out of the percentage. Here we are applying the Bayes theorem. We are putting the values and we will get this result, which in fraction we will get as 1 by 750. Uh, from that we can assume that one patient out of 750 patients has meningitis disease with a stiff neck. So this count we have calculated from this using Bayes theorem. Just go through once.
So how to determine P of B and P of A? Which one will be at the bottom?
That you have to see actually here what we are going to calculate actually. So we are going to calculate the uh, patient having disease meningitis with stiff neck. So we are taking this disease meningitis as B, and with stiff neck we are taking it as A. Then PBA we have to calculate. With the question only you have to associate with what we have to calculate, PBA. So like this only we can associate with the question. Okay, now we will move on to next example, next question. So from a standard deck of playing cards, a single card is drawn. The probability that the card is king is 4 by 52. Then calculate posterior probability P, king face, which means the drawn face card is a king. Here we are again applying the Bayes theorem, and from the data we can conclude that there are total 4 cards, 4 king cards in the deck, and the 3 different type of face cards, each is 4. So that face card each is 4, then 3 into 4, 12. 12 out of 52. Total 52 cards are there in the deck. So we are calculating the probability of king, uh, 4 out of 52, and the probability that a card is a face, 12 out of 52. Then probability of face of king is 1, because we are assuming if king is coming 1 in the face card, then it will be 1 only. Then we are putting the values in the formula, and we are getting the probability 1 by 3 that a face card is a king. Let's go through this example. I will also share this after the class.
Sir,
Yeah.
sir, what is the meaning of posterior probability?
So that posterior probability in the Bayesian reasoning. So this is the updated probability of hypothesis after considering new evidence. It reflects how much one should believe in after uh, seeing the new data. So this I have written, I will share with you posterior probability, then uh, pure probability. This will come in also in the next slides. This I will share. I have written this. I will just, you can see, I will share it.
Okay, sir. Thank you, sir.
Yeah, just see once I will share. So in Bayesian reasoning, these terms will be included. Just see once. Other terms we will see later. Just see the Bayesian reasoning and the posterior probability. This will also come in the next part. Okay, now we will move on. Bayesian reasoning, so that I have already written, you have seen. So this is another type of reasoning where the method of statistical inference and decision making based on Bayes' theorem. And it allows to update beliefs or probabilities about an event based on new evidence or information. If something is newly added in that data, so that data we can get the outcome based on the new updated data. So this is the formula. Hypothesis is a situation where, suppose we are considering that some situation will true or not. So we are considering it. That we will see with a solve example. Just see the formula once.
Sir, what is the meaning of capital D and small h?
That a hypothesis, small h is, and d is data. You can write with the capital also, so no issue. We'll see this first formula with an example. Let me share again. So this one kind of problem we are dealing with. Bayesian reasoning we will apply. So suppose the doctor is trying to diagnose a disease, rare disease, then your probability is, or the prevalence of the disease is the probability that a randomly selected person has the disease, we are supposing, is 0.01 or 1%. And true positive rate or the test sensitivity is the probability of testing positive given that the person has disease, that we are writing as P positive dash disease as 0.95 or 95%. Then true negative rate or test specificity, probability of testing negative given that the person does not have the disease, that will denote as P negative, no disease, equal 0.90 or 90%. Therefore, probability of testing positive given that the person does not have the disease is false positive rate minus P positive dash no disease equal 1 minus P negative or no disease, that is equal to 1 minus 0.09 equal 0.10. So this is the formula using that we are trying to solve with the Bayesian theorem. At last we will put all these values in the Bayes theorem and we will get the result. This just see once.
Sir,
Yeah.
sir, I am not able to understand the difference between test sensitivity and test specificity.
Yeah, test specificity. So there is true positive rate and true negative rate. That's we are that it is means told as test sensitivity and test specificity. So the positive testing is that the person has the disease. So definitely it is P positive by disease we are writing. So it means it has the disease, and the negative is the person does not have that disease. So we are writing it as P negative or no disease. Just you understand it like this only. This is the term they are using actually for this true positive and true negative. This will be given in the problem also.
Okay, sir.
Yeah. So this kind of uncertainties are there, as we even though the person is having the disease or not, also then there may be some situations that the result may be or may not be true also. So that kind of uncertainty is also there. So this is solved in this problem. And this So in AIML also, you will come to know about these terms: true, positive, false, negative. So there's kind of terms you will come to know. So in this problem also, we are calculating on this. let's see the application of the base theorem here. After all those calculations, we are putting the values in the base theorem. So it's the person actually having the disease and also is tested positive. So that's what we are calculating here. This proof positive. At last, after calculating all these, we have come to know that with positive test result, only 8.76% chance that the person actually has the disease. So that uncertainty we are dealing actually. Even though the result is positive, but the chances of actually having the disease among the person is very low. So it commonly appearing in the medical field and is also known as base rate fallacy, where low prevalence of disease affects overall probability despite positive result. So this kind of things comes into the picture. So using Bayes theorem, we are solving this. We already have seen the hypothesis of a person having actually disease and is also tested positive. So there may be some false hypothesis also, which we will be solving with Bayes theorem. So here I mentioned Bayes theorem for false hypothesis. Let me first share the slide. Not hypothesis, so this formula we can use. One is hypothesis and one is not hypothesis. So it is opposite of that. Formula is kind of same, but the hypothesis is not holding. So this we can use. This we will see with an example also. No, let me show you that example. So there are two hypotheses. Hypothesis is patient has specific disease, and not hypothesis is patient does not have the disease. And the data is patient tests positive for disease. Also, this is given as pH is 0.011%, disease prevalence, and probability disease with hypothesis is 0.95, 95%. That is the sensitivity of the test, and the probability of disease. The hypothesis is not true is 0.10 or 10%, false positive rate. For that, we are calculating the prior probability, like the example before. And then calculating the total probability of the data. Then finally, we are getting all the values, and we are putting that in the Bayes theorem for not hypothesis formula. And at last, we are getting the result as 0.912 or 91.2%. Just see once. What it means? It means that given positive test result is still 91.2%, and the chance that the patient does not have the disease. So that we are calculating with the Bayes theorem of not hypothesis. Then one more form of the Bayes theorem is the odds form of Bayes theorem, or the Bayes rule, which is the relationship between prior odds, the likelihood of evidence, and posterior odds. So it means it is the reformulation of Bayes theorem that uses odds ratio instead of probabilities. What we have seen in the earlier two examples, there we are using the probabilities. But here we are calculating the odds ratio. What are the odds ratio? How we can calculate? That is another formula we are having. So just go through this prior odds and posterior odds. Here you can write the evidence E or data D. In the formula in the slide, there it is mentioned as data D. This can also be written as E. Just now see the formula.
কেলা কি কইলি তই মাছ
I request to mute your mic. So this will be the formula for calculating the odds form of the Bayes rule. This posterior odds, likelihood ratio, and prior odds. So this is we are calculating. For this, I have not written any example. I will write one example also, so that you can get the better idea how and what it can be used to calculate. Just see the formula once. I will share with you afterwards.
Sir,
Yeah.
sir, in prior odd and posterior odd, why there is a need to calculate belief in hypothesis? What is the use of calculating the belief in hypothesis for analysis purpose?
So here is mentioned that you will get the better idea with an example only. This prior only the representation of belief in hypothesis before observing the evidence or data. So it is the prior only. So posterior odds we are calculating using the two prior odds and likelihood ratio. Okay, so after this we will see the temporal reasoning. So what is your temporal reasoning? It is mainly related to two large areas, cognitive science and cognitive psychology. So basically these two are the fields where the temporal reasoning can be applied. So whenever we are seeing the objects, uh, suppose we are having one object and it has a different kind of characters or appearance. So what we can uh, draw from that it is tall, short, large. So how we can represent all those characteristics of that particular object. So that kind of things we can directly apply using the temporal reasoning. There it is already mentioned that it is used for the object detection in 3 steps: object detection, object recognition, and modeling. And this is for detecting the object, we are taking it as an object, as a cuboid with x, z as the base corner and y top bottom base for mass, center, and height. So we are representing the object in the 3D plane as a cuboid, and then we are recognizing the object. So the machine learning after some classes, you will get to know how machine learning can be applied for the object. We are having some data, so there the objects are different kind of objects are there. So database uh, model we are considering here in this example. So there are pedestrians, cars, poles, and some are unknown also. So that kind of objects are there that we are having one as single data. So that kind of data we have to recognize and we have to label them. And there we will having also the features for them. So what will be the features? That object dimension, pattern matching score, then texture, motion, HOG pedestrian score, HOG pole score. Then all these kind of things are the features we are extracting from all those objects in the data we are having. So these features we have to recognize, then only we can classify them accordingly, and we can do our model prediction. So these kind of things we'll again see in detail in the later classes. So for now, only to understand the temporal reasoning, so that things we just know. And all the things we have to recognize so that we can predict properly, and all the features that are uh, extracted from those objects. So that are the main things required. The next slide also, it is showing that only the applications, how we can apply the AI. Okay, then I will share all these things with you in the group, and also I will share that the problem what we have seen about the probability in the first example, that I will again check and share with you. And one more problem I will share, how we can solve that, what's form of the base rule in the group. Just go through it once, then only you will able to understand. It is quite a mathematical things, so we have to go through it one by one only. So anything you want to ask?
So, I
Yeah.
have a question.
Yeah.
In initial class, you have mentioned 6 different reasoning, right? So, deductive,
Yeah.
inductive, and in this class, you have mentioned Bayesian and temporal reasoning.
Mm.
So
Yeah.
these two reasonings are comes under the probability questions oriented problem, sir.
Yeah. In the probability, it comes under that only.
Okay, sir.
Yeah. And that odd form is somewhat different. So that I will show you with an example.
Okay.
So yeah, that probability is kind of uncertainty what we have discussed in this class. So that is the thing for this reasoning.
Okay, sir.
Yeah.
Thank you.
Good evening, sir.
Yeah. Good evening.
So actually মোৰ এটা question আছিলে মানে আমাৰ হেৰি syllabus বা আজিৰ class related নহয় but actually মোৰ niece মানে তাই পতককে ফোনটো disconnect কৰি দিলে so it's related to our attendance skill like so কেনেকে কি count হ'ব
Attendance to already ক্লাছৰ আমি লৈ আছো তোমাৰ এখন sheetত, Google sheetত।
okay okay
হেতুতে
so
আমি
মানে
কাউন্ট
class
কৰি আছো। তুমি
মাজত
জয়েন হৈ
individually
আছা যদি একো নাই, তুমি আকৌ যদি পিছতো জয়েন কৰিছা হেতু তাত কাউন্ট হৈ যায়।
okay so actually মানে পতককে এতিয়া মোৰ ভাগিনজনী হিতা পতককে disconnect কৰি দিলে ক্লাছৰ মাজত তো মই আকৌ মানে জয়েন কৰিব লগিয়া হ'ল so সেইকাৰণে সুধিলো
একো নাই, জয়েন কৰিলে হেতু আহিব আৰু এটেন্ডেন্সটো হেতুতে কাউন্ট হৈ যাব।
আচ্ছা আচ্ছা okay fine sir thank you
Yes. Okay, then we are concluding here today's class. This I will share in the group. Just go through it once. And if you are having any question, then also you put it in the group. We'll see.
Sir,
Yeah.
sir, in the last slide, which is being presented now, Kinect files and mocap files, how these two files are different from video files, which we usually play in our computers and laptops.
Kinect files and these mocap files. So these
Yes, sir.
these are actually that what in this temporal reasoning we have seen that it is taking as an object particularly. So it will be like in different axis. It will take the object not as what we are seeing. So it will see as an uh, in the axis. So like that it will see. But in the
Okay, sir.
videos, there we will be seeing as an individual pixel only. So it will be in details. We will see how, and in the application also we can see. But these kind of things are somewhat more advanced. That we have to take sensors and all. So this you can here see that the child is playing. So one sensor is capturing all this data. So it is somewhat more advanced. You have to go through it with the different sensors and all.
Okay, sir.
Yeah. Okay, then we are concluding here. We will see you in the next class. Okay, then.